Am I audible, guys? Can you able to hear me? I'm calling you.
Yes, sir.
Yes, sir.
So, if you want to make the satellites to revolve around the Earth or any kind of thing, we need a closed path. It's not that we need a open curves. That is what parabolic curve or the hyperbolic curve. Clear? So now, if I take the satellite, which is revolving around the Earth. So let me consider now. So if this is the Earth, so now the satellite is revolving around the Earth in a particular orbit. That is what, let me preferred path is, what is the path? Circular path. Okay. So now we all knows that mass of the Earth is capital M. Let me take the planet is revolving around different positions. So different positions around the Earth in a particular orbit. So radius of the Earth is R. Now you can see, we all knows the circular motion. If any object is revolving around the circular path, we all knows that at every point, the velocity is acting perpendicularly and the force of attraction which is acting towards the center, which is called it as a what force? Everybody?
Centripetal force.
Centripetal force. Do you all remember, everyone? Please respond, guys, all of you. So let me consider now, this is the satellite here. And this is the positions, different positions of satellite around the Earth I am drawing. So now if I have taken, just imagine if the satellite is revolving, having a small m mass, and here the escaping velocity, the velocity is v, so that at that point, the velocity, another force which is acting towards the center. What is the force we used to call it as? Centripetal force. Am I right or wrong? So at every point, if I have noticed it, so this is the velocity direction of satellite, and this is the centripetal force. This is the direction of velocity, and this is the direction of centripetal force, FC. Direction of velocity, and direction of centripetal force. Direction of velocity and direction of centripetal force. Am I right, everybody? Please respond, guys, all of you. So we have studied or not?
Yes, sir.
Yes, that is what. So now if you have noticed it here, all of you, so we all studied already. Can you tell me what is the centripetal force formula, all of you? What is the centripetal force formula which we studied? Mr. Rudreswar, Pradosh? What is the centripetal force which is binding system? So which is binding this satellite to revolve around the Earth? Anyone? Centripetal force formula? mv square divided by r. So what is r? Distance between the satellite and the center of the Earth. That is what. So let me take, if here is the satellite, then this is the distance between from the centers, which is what is equals to r. So now we all knows that centripetal force is causing because of some force. That force is called it as this chapter name. What is that force, everybody? Can you tell me? Centripetal force is equals to force of what? Force of
Gravitation.
Force of gravitation. So what is the gravitational force between these two bodies, satellite and the Earth? Everybody, force of attraction. The force of attraction is equals to capital G into mass of the Earth into mass of the satellite divided by square of distance between them. Gravitation. Do you remember, everybody? Yes or no, guys? So centripetal force is causing because of gravitational force only. Because of gravitational force. So gravitational force is only causing for centripetal force, providing the centripetal force so that both are equal. So we can say centripetal force equation is mv square by r, and gravitational force is g into capital M into small m divided by r square. So what is in this? Both common. Small m will get cancelled. R and r square will get cancelled. So v square is equals to gm divided by r, or v is equals to root over gm divided by r. This is the formula for our concept. That is what? Orbital velocity. So any kind of planet, the satellites revolving around the planets is, if you want to find the orbital speed or orbital velocity, this is the formula, root over gm divided by r. Please write it. Everyone, anybody having any doubt, you can ask me. Are you clear, everybody? Mr. Pradosh, understand? Manya and Samya, Sai Karthik. So once again, I'm saying, if a body is revolving around the circular path, we all knows that, we already studied. At any point, velocity is acting perpendicularly to the force of attraction. That's what centripetal force. Any place. So the particle, if I take, that is what direction of velocity, and centripetal force is acting towards the what, everyone? Center. Am I right, guys? So now the centripetal force is causing because of gravitational force only, force of attraction. So that's all it is. If you equate them, what is the centripetal force formula? I already taught you, check your notebooks. Mass of the object into square of velocity divided by distance between the planet and that mass. That is what R. So both if I equate it, what will happen? Orbital velocity V is equals to root over gm divided by R. And this is the formula which is valid when the satellite is revolving around the sun or a earth or a moon or whatever it is. If the satellite is revolving at a particular distance above from the sun, that is what, from the earth or whatever it is, the planet, some planet, you can take it, planet to the satellite. So distance between them from their centers is considered as a R. Now then what is the orbital velocity formula? Root over gm divided by R. Now, if the satellite is revolving, please remember, if satellite is revolving very close to the earth surface. So remember, most of the satellites what we have around the earth, maximum number of satellites are very close to the earth only, because that is the purpose, to monitor the geological features of the earth, the weather forecasting changes, everything. We are having many satellites even in India. So all are very close to the earth. They are revolving around the earth, very close distance. Very close in the sense of it is a less kilometer distance. So if this is the planet, so then you can see approximately the distance between them, which is equals to something. Anybody can tell? Approximately, which is equals to, R is equals to what approximately? Radius of the earth. Like we can consider G is equals to gm divided by d square. So if any object is present above the surface of the earth, then the distance between them is equals to radius of the earth. So gravitational force of earth is equals to gm divided by r square. Do you remember, Mr. Pradosh?
Yes,
Can you hear me, everybody? That is what. So if any planet is revolving very close to the earth surface of the earth, that is what any satellite, then in this situation, so that velocity, orbital velocity is equals to very closely to that, then orbital velocity is equals to V. What is the formula? We got it, everybody. Gm divided by R. Small r will equals to what? Capital R. So orbital velocity is equals to gm divided by capital R. Now, we all knows that from gravitation formula, gm divided by r square, then from that capital Gm is equals to gr square. So I'll replace it here. So orbital velocity when the satellites are going closer to the earth surface, then r and r will get cancelled. What is the orbital velocity? Which are moving closer to the earth surface? Everybody? Which are moving closer to the earth surface. What is the gravitational? What is the orbital velocity? Everybody? Very close to the earth surface. Very close to the earth surface. Then what is the orbital velocity formula? Everybody? Very close to the earth surface. V naught is equals to root over gr. And you know, for this earth, for the earth, orbital velocity is approximately equals to 7.9 kilometer per second, which is equals to 8 kilometer per second. That is what I said. 8 kilometer per hour means the satellites will revolve around the earth in a what path? Elliptical path or circular path? Everybody? They'll take in a what path? All of you. Point number 2, circular path. That is what. Only I am keep on shouting. You people are not doing anything. That's what I can make it. Nowadays, brothers also completely changed. Nothing doing work. That's what. Any doubt you can ask me, Mr. Sai Karthik, understand? So very close to the earth. If any satellites are moving very close to the earth, then orbital velocity is root over gr. If the normally, what is the formula? Everybody, revolving orbital velocity? Orbital velocity is equals to root over gm by r. If any planet is moving closer to the surface of the earth, where approximately r is equals to r, radius of the earth is equals to distance between the satellite and the earth, then the formula is orbital velocity is equals to root over gr. Clear, everyone? Now, let us see the last concept. So if I have taken, when any planet, any satellite is revolving, that is what? From the surface of the earth, if you want to launch the satellite, what is the escaping velocity? Anybody? From the surface. At the surface, what is the escaping velocity? Root over 2gr. Am I right or wrong? And very close to the surface, what is the orbital velocity? Root over gr. So relation between orbital velocity and escape velocity of the surface of the earth. So if you have noticed it, so very simple. Escaping velocity is equals to root over gr. Orbital velocity is equals to, if you do that, root over gr. So which is equals to root 2 into root gr divided by root gr. So gr will get cancelled. So what is the relation? We'll get it, everybody. Escaping velocity is equals to approximately root 2 times of orbital velocity. Do you all understanding, everyone? Everybody clear? Please
Yes,
respond. That is now. Sir, what is the difference? Very simple. We all knows that what is the surface, what is the escaping velocity? At the surface, escaping velocity is equals to how much, guys? 11.2 kilometer per second. And what is the orbital velocity? Approximately 7.9 kilometer per second. So now, if you find the difference between escaping velocity and orbital velocity of Earth, which is equals to, that is what? Root over 2gr minus root over gr. That is what? Escaping velocity minus orbital velocity. So gr, root over gr is the common, which is equals to root 2 minus 1. So that is what? Which is equals to how much, everybody? 11.2 minus 7.9, which is equals to 3.3 kilometer per second. So root over bracket, root over gr into root 2 minus 1, value we got it. How much it is difference? 3.3 kilometer per second. So this is the difference between escaping velocity and orbital velocity of Earth. This is what is the concept of orbital velocity and escape velocity. So please remember, escape velocity from the surface formula is root over gr. Orbital velocity, which is closer to the surface, is root over gr. For normal condition, what is the formula? For normal condition, what is the escaping velocity? Anybody? For normal condition, what is the escaping velocity formula, guys? Root over 2gm divided by r. For normal condition, orbital velocity, what is the formula? Orbital velocity formula, root over gm by r. This is what is orbital velocities. And if it is in normal conditions and on the surface of the earth, this is for surface of earth, what is the formulas? This is the normal conditions. So this is what is about today's class. I hope you all understand very clearly. Anything doubt, you can ask me. Then, tomorrow's class will solve what is the time period of a revolution of the satellite, how much time it will take to revolve around it. And from that, the proof of verification of Kepler's third law. That is what? What is Kepler's third law? Square of time period of any planet is cube root of average radius between the planet and the sun. Am I right, guys? We have been done or not? Day before yesterday, I have taught you Kepler's third law. So how it will become Kepler's third law? So that we will discuss it in our tomorrow's class. And what is the time period of a satellite which is very close to the earth, how much it is, and then what is the energy of the satellite, and what is that, either it is a positive, negative, and all that we will discuss. And the last concept of this one, except Kepler's laws, verifications, and proofs, Geostationary systems is there. That is what types of satellites and what is the geostationary satellites. So these things we'll discuss in the tomorrow's class. So tomorrow, mostly I'll take it in the afternoon class. So by the time I will update the things before morning, so you can follow according to that. So that this chapter also will complete. I hope you all understand. Anybody having any doubt, you can ask me. This is what is about the today's class. Are you all clear, guys? Everybody? Mr. Kadir, Pradosh, Murali,
Sir.
and Samya. So this is what is all about. What is the escape velocity and what is the orbital velocity of the satellites when we are launching from the surface of the Earth. So this is the most useful concept for space and technologies. Those who are working on space and technologies and all, every aspects they have to follow this one. You can see that Chandrayaan 3 launching path, you can notice it. So they have been given how it will be taken. So Chandrayaan 3, if you have noticed it, they have been given in the Google missions. You can see that how the images will be there. So Chandrayaan 3 orbital velocity, I think YouTube status and all, you can notice it. Yes, I will show you. You can all see that. These are all the things they will calculate like this only. So first, see, if it wants, it cannot directly escape from the Earth gravity. Do you understand, Pradosh? You can see, have you noticed it? It is taking circular path. It has been launched from here, Sriharikota, Andhra, Nellore district. It is taken. Next circular path. Next what path? You can see circular path. Next light elliptical. Next elliptical. Next elliptical. Then only it is getting. After this much distance only it will attain the escaping velocity. Then only it will reach us to the moon. Do you understanding? Again, moon launching. What will happen? You can see here, everybody. Lunar transfer project. Do you understand, Laksha, Ishali, everybody? So then moon launching also you can see. So when it wants to revolve around the Earth, then it needs to follow closed curves. That is what circular path or elliptical path. But when it wants to escape, it needs to take the what? Parabolic path. It needs to take the parabolic path or what path? Hyperbolic path, 4 and 5 open curves. And once it will enters to the see that this is Earth gravity and this is the moon's gravity. So it has been taken the parabolic path. Have you seen the brothers? Parabolic path after revolving around the Earth. It is taking the parabolic path, escaping velocity, and it is reaches to the moon surface. Now moon also directly it cannot be. It has to be controlled everywhere. It will take like velocity keep on decreases, and finally you can see that it has been everything regulated from the down. That's what satellite operatings. So it is taking elliptical path and finally it will be launched, settled. That is what landing. We have been all watched Chandrayaan 3 landing. That is how it will be takes place. Are you clear, everybody? How it will be path explained. Chandrayaan 3 path. You can notice it. The beautiful concept what we studied is exact phenomena of how the Chandrayaan 3 has been launched. So no satellite can escape directly to the moon. It has to be multiple revolutions around the Earth. You can notice it. Circular path, elliptical path, and different. Why it is? Because to attain that velocity, escaping velocity, it needs to be keep on revolving. So then only it will escape. It will attains the escaping velocity, which can go away from the Earth gravity. Then from there open curve, either it is a escaping velocity greater than 11.2, then only it will go like this. Are you clear, everybody? I hope you all understand. Any doubt you can ask me. The most important concept for every satellite launching will work with this only. So in this values calculation, if they will be committed any error, that is what the satellites will collapse. That is the principle actually behind it. Okay. So thank you, everybody. We'll meet in tomorrow's class. Everybody, good night. You sleep. It's already time up. We can wake up morning. Thank you all, everyone.
Thank you.